Alright, in this Algebra 1 video, we're in Chapter 2, Lesson 4. We're talking about solving equations with a variable on both sides. Our objective is, as the student, I can solve equations with the variable on each side because I will simplify both sides first and then we'll isolate the variable using the skills I've learned. Now, I want to point out, you guys will notice this should sound very familiar to stuff we talked about last school year. Many of my students remember the mutant chicken method to help you prioritize when working on how to move your variables to both sides. Because in this section, we're talking about equations to where you have a variable on both sides of the equal sign. For example, what I wrote at the bottom, you notice the variable m is on both sides of the equal sign. We're talking about how to solve that. By the way, as a side note, the solution to that would be m equals 43. That would be what would make it true. But we're going to talk about how to solve that. But like I said, this should sound very familiar to what we talked about last year, hopefully. Alright, so we're going to start this with a couple examples. We're going to jump right in. Before I talk to you necessarily about the summary steps or anything like that, let's go ahead and knock out a few examples, hopefully refresh your memory. And if not, if you don't, you've never done this before, that's okay. We can work on that now. So here's what we're going to do. When you have an equation with the variable on both sides of the equal sign, your first goal is to simplify both sides. Notice, that left side is completely simplified. But look at the example on the right. That left side is not simplified. We've got some parentheses we need to take care of. So the first thing we're going to do is simplify both sides. In this first example, they already are. In the second example, we'll have to use the distributive property to simplify both sides first. So let's get to that. So on the first one, we don't need to. All we can do is get started. So once you're simplified on both sides, you're going to move your variables to the same side of the equal sign. Last year I recommended always moving the smaller variable towards the larger variable. This variable is negative 2x, this one is positive 4x. So your smaller one is negative 2x. So now I'm moving it to the other side. You move it to the other side by doing the opposite. It's minus 2x, so the opposite is positive or plus 2x. So move it to the other side. On the right side, we're left with just 10. On the left side, we have 6x minus 8. We now have a two-step equation that I know you guys know how to solve, especially from the last video. So now I'll finish and solve this one through. And if you did that, it should look something like this. You should end up with x equals 3. Now that's doing it. Now, as a heads up, for a brief reminder of the mutant chicken method, essentially we hate chasing two chickens at once. We have two x's going on. So when you're on the farm trying to chase the chickens, it's much more effective if you shove those chickens together and you make one mutant chicken, so you only have to chase one more chicken. Now, for more details on that, hopefully that rings a bell. Check out the other videos from last year where we talked about that technique. Okay, now the example on the right, we're going to do what I said earlier. Before we can start moving our variables around, we've got to simplify both sides fully. So in this case, we're going to use the distributive property on both sides. That's what's going to happen. So let's show our work and do that. And if you use the distributive property on both sides, this is the written out steps, and then you'll just simplify and state what you have on each side. You should end up with 9m minus 6 equals 6m plus 6. Now you're ready to proceed as you did on the other side. Now it just looks like the same thing the other side looked like. Let's move our variables to one side. And you help avoid negative variables if you always move the smaller variable towards the larger variable. This currently is positive 6m. Since we're moving the entire term, terms are separated by addition or subtraction. So 6 is a term, 6m is a term. Technically this would be negative 6 as a term because of the minus sign, and 9m. These are our terms. If we're going to move an entire term to the other side, you do the opposite. It's positive 6m, so the opposite is negative 6m, or minus 6m in this case, is what we need it to be. We're left with 3m on the minus 6 on the left side, and on the right side, those cancel. We're just left with positive 6. You know it's positive because of the plus sign in front of it. Alright, we now have a two-step equation, so now solve it from here. And you end up with m equals 4. So what we did is we simplified both sides, and then we used the same process that was used on the left side. Now I want to point out as a reminder, this very first step on that last one, that first step we turned it into, that is called an equivalent equation to the original. You know they're equivalent equations because you use the property of equality to find them, one of the properties of equality, in this case the addition property of equality, but also because this and this both have the exact same solution. Now the same thing goes for this. Our original equation and then the one that we turned it into, those are equivalent equations. This one is also an equivalent equation, and this one is also an equivalent equation to all of those. They're all equivalent because they all have the same solution for m, or they all were the result of using the properties of equality. So the general summary steps for solving equations, in general, these are your three main steps. So a lot of people like to have steps to refer to. Sometimes seeing them and writing them helps them a lot. So this is the general summary you always want to do. So step one, simplify the expressions on each side, which is what we did first, and use the distributive property if necessary. Step two, move the variables to one side and the numbers without the variables to the other side. And your final step will be to use multiplication and or division to finish solving and isolating your variable and solving for it. These are the general summary steps for solving equations. Now I want you to try. There's two examples on the screen. I know I'm evil. I've got fractions in the first one, and in the second one I think the answer might actually be a fraction, but work through both of these, and yes, definitely the answer to the second one, I'll give you a hint, will be a fraction. So press pause, try these out, use your fraction skills, go step by step, but I promise you it's the exact same steps and processes from what we just got done doing. But in this case, just keep track of your fractions. Hit pause. Alright, so the answer to your first one is v ends up equaling 9 to that one. Enter that in red. And then your answer to the second one, y ends up equaling 2/3. So now, if you already got those correct, you can fast forward across these next couple slides where I'm going to explain how to do these problems. But if you didn't quite have these correct, or maybe you want to confirm some of your reasons for doing it, feel free to at least fast forward to see the steps and the explanations. But as a bare minimum, in your notes, you need to have the written steps and work shown how to solve these solutions. So if you need help with this one, for example, go ahead and watch and see how this goes. Alright, so you want to start by moving since both sides are already simplified, you're going to start by moving your variables to one side. So in this case, you're going to move the smaller one towards the bigger one. The smaller one is negative 2/3 v, so you're going to add the opposite of negative is adding, or minus, so you're going to add 2/3 v to both sides. Or cancel on the right side. Now, if you do that, on the left side, you're going to be left with 4/3 v, using your fraction skills to keep the denominator and numerators add together. So 4/3 v minus 6 equals 6. Add 6 to both sides. You have 4/3 v equals 12. So now you just have solving with rational coefficients. This is something we mentioned in the last video, how to solve with rational coefficients. So just for the sake of space, I'm going to move that over to the side. You learned that when solving rational coefficients, you move any coefficient to the other side by dividing, since all coefficients, since they're touching, means multiplying. So divide both sides by 4/3. On the left side, you're left with v. On the right side, you have 12 over 1. Now, how to divide by a fraction? Some of you call it keep, change, flip. Some just know to multiply by the reciprocal. Whatever you call it, make sure you set it up properly. You can use the shortcut here if you want. I'm not going to because I don't want to confuse those who don't already know it. So go straight across. 12 times 3 is 36. 1 times 4 is 4. 36 over 4, well, that simplifies to 9. And that's where we got our answer, v equals 9. So make sure you have the full steps shown how to solve this solution. I ran out of room, so I had to move over to the right to finish it. Alright, now if you need an explanation, if you don't need an explanation for this one, feel free to hit fast forward, just make sure you have the proper steps, and now and then work your way through. If you do need help, make sure you listen to the explanation. We have to start by simplifying both sides using the distributive property on both sides. So I'm going to go ahead and do them both at the same time. So we'll have 7 times negative 3y. I'm just going to hit pause to write that out. Alright, so if you use the distributive property on the left side, you end up with negative 21y plus 14. On the right side, you get 24y minus 16. Now we're going to apply the same skills. We're going to move the smaller variable towards the bigger one first. The smaller one's the negative one, so we're going to add 21y to both sides. Cancel on the right side. 14 equals 24 plus 21, excuse me, that's 45. So we have 45y minus 16. Now you have a two-step equation, and I think many of you can take it from here. You'll end up with 30 equals 45y, and I'll just finish from there by dividing both sides by 45. And this is where I meant you're going to end up with a fraction. You're going to have to simplify 30 over 45. So y equals 30 over 45. 15 goes into 30 2 times. 15 goes into 45 3 times. So you end up with 2/3. So the answer is y equals 2/3. Once again, sorry I ran out of space. I'd move over to the side, but you would just have that below yours. All right, when solving equations, in this case, in solving equations with the variable on both sides, there are two special circumstances that can happen. You can sometimes end up with no solution, and what will happen is, what that means is, that means no value will make the equation true. And in other words, when you're solving it, you'll be left with a false statement. For example, let's say you solve the question all the way down, and you end up with something like -4 equals 7, and that's what you're left with. There's nothing else for you to do. That's a false statement. So because that's a false statement, and you know you did all the math correctly, that means there's no solution to that equation. That's what that would mean. Now, an identity, on the other hand, they call it identity, but essentially it means all real numbers are a solution. And what that means all numbers will make the equation true. So if you're solving and you go all the way down, what's going to happen is, just like in the last one, notice there were no more variables. They canceled out. We were just left with -4 equals 7. Now, in this one, when you go through, so in an identity, all your variables will cancel out just like in the last one, but in this one, you'll end up with a true statement. For example, 5 equals 5, and that's a true statement, so that means is no matter what you plug in for your variable, you're going to end up with a true statement. Your equation will be true, so that means all real numbers are solutions. So now I'm going to show you some examples of these. Alright, so these are examples we're going to do together. Let's take a look at these special circumstances. Let's do the one on the right first. Now, we're going to start by moving our variables towards each other. In this case, they're kind of tied. We can't really see who's bigger, who's smaller. So we're going to add 6y to both sides. Now, what you'll notice on the right side, minus -6y plus 6y, well, that's just 0. They cancel out. On the left side, -6y plus 6y, oh, those cancel out. Okay, so they're both gone. So that means we're left with -3 equals 5. Now you realize, oh wait, all of a sudden I can't do anything with this, I have nothing else, and this is a false statement. Because this is a false statement, we're going to say no solution. Obviously, double check, make sure you did your math correctly, but in this case we can say no solution because our variables canceled out and we left with a false statement. Sometimes you might see this coming. You'll notice, if you looked at our equation, we had a -6y on this side, a -6y on this side. Meaning, if we're thinking of like a balance scale, the left side equaling the right side, they both were already on both sides, so you can almost pretend they weren't even there. And because of that, we were left with a false statement. So that's kind of, you sometimes can predict these, but for the beginning, practice them first until you know for sure that's what's going to happen. Now let's turn our attention to the one on the left side. Same thing though, just like before, simplify the equation by using, in this case, the distributive property. We end up with 12 plus 8q on the right side. On the left side, we have 8q plus 12. Now, this one might already be kind of obvious because look what we have. We have 8q plus 12 equals 12 plus 8q, to where they literally use the symmetric property. So the left side is equal to the right side. So you may already be able to notice, well, hey, if the two sides are equal to each other, it means no matter what, it's going to be equal. But just to show you what would happen if you continue to solve, this is what would happen. You would move your 8q to the other side, and you would notice all of your q's would cancel, and you'd be left with 12 equals 12. Well, 12 equals 12, that is a true statement. So that means is all real numbers are a solution, all real numbers. Now, so any number for q would make this a true equation. Or sometimes you can also write identity. Sometimes that name isn't clear enough to make us understand what it is. What that's essentially saying, though, is that essentially saying your left side is equal to your right side, that it's already equal, like anything is a solution. Now we're going to have some examples for you to try. Okay, so you guys try these two examples and show your work and make sure you do them, and then check yourselves. So hit pause. So for the example on the left, you would use a distributive property and move 3 d's all to one side. Your d's would cancel and you'd be left with a false statement. Therefore, no solution. Now try the one on the right if you haven't done so already. So on the example on the right, you use the distributive property and then combine like terms. The +3 and -5, those combine to give us the -2. And then now you're going to move your a's all to one side, and you would find that they both would cancel, and you'd be left with -2 equals -2. That's a true statement. Therefore, all real numbers are solutions, aka it's called an identity. Now we're going to talk about one more final topic, and then we're going to be all done. Alright, we'll make this our final example. This is like a geometry / algebra cross type question, and this could be an example of what you might see on a standardized test. And the question, the instructions would say something along the lines of, find the value of h so that the figures have the same area. Meaning, what value can we plug in for h that will make these two triangles have the same area? So this is where it could be technically, you could guess and check and try to find your way through it, or you can use what we know about geometry and now algebra to create an equation that we can see that will make them equal. So in other words, they're asking, when will the area of the first one, so that, let's say that was a formula for the first one, when is that going to be equal to the second one? So here's what we're going to do. Let's set up a formula, an equation in this case, using the formula with the first triangle. Half times base times height. So for the first triangle, that's half, the base is 6, and the height is just h. We don't know what it is. Now, when is that going to be equal to the second one? Let's do it for the second one. Half times base, well the base is 10 in this case, and then the height is h minus 2 for this one. H minus 2. Look what we now have. We now have an equation with the variable on both sides. Solve this and you'll have your answer. I highly suggest on the right side, you go ahead and simplify that first. So the half times 10, that's going to equal 5. So I'm going to go ahead and rewrite that with a 5 in its place. And also, while we're at it, let's go ahead and simplify the left side. If we have half times 6, we know what half times 6 is. It's 3. That's what I wrote in highlighter. So I'm just going to write both of those. I'm going to put a 3 over that one, I'm going to put a 5 over that one, and I'm going to get that dog. Alright, so if you do that, you're left with 3h equals 5 times h minus 2. Sorry about that, guys. Alright, so let's use the distributive property on the right side. And so we're left with 5h minus 10, and on the left side we still have 3h. Now, let's now use the mutant chicken method. Let's move the smaller variable towards the larger variable. The smaller one is 3h, the larger one is 5h. So minus 3h on both sides, they cancel on the left side. And now on the left side, we're left with 0. If there's nothing over there, if you empty one side of the equation, it's 0. On the right side, we have 2h minus 10. So I'm going to rewrite that over on the side where I have room, and then we're going to continue. As of now, you now have a two-step equation for you to solve to finish solving for h, and you'll all be done. Most of you can finish just from here. And if you do that, you're left with h equals 5. That means 5 is the value that will make the area of these two triangles equal. And if you're not sure if I'm telling the truth, let's test it. We said that the area of the first triangle was half times base times height. Well, that's half times 6, and now the height we just found out is h. It's 5. So that means we have half times 6 times 5. Well, half times 6 is 3, and then 3 times 5 is 15. So the area of that left triangle is 15. Now let's do the one on the right. Half times base times height. Well, the base is 10, so half of 10 is 5. So we already know, just like we kind of did here, and we got that 5 right there. So let's go ahead and plug in 5 for the h. So if we put a 5 there, we'll have 5 minus 2. Well, that's 3. So what we would have, we said half times base, well that equals 5, and then this height portion is now going to be 3. So we have 5 times 3. Well, 5 times 3, that's 15. So it means the area of that triangle is also 15. So it does show both those triangles have an area of 15. So h is the value that would make the area of both of these be the same. H equals 5 is that value. Alright guys, so brief recap and we're all done. When solving equations with a variable on both sides, simplify both sides, and then you're going to move your variables to one side and then move your numbers away from it, and then until you get your letter all by itself like we did in these. You tried some examples. Then special circumstances. If you're left with a false statement and your variables canceled out, there's no solution to that equation. If your variables all cancel out and you're left with a true statement, it's an identity. Here are some examples, and you tried some. Now, then we did our connection with algebra and geometry. Alright guys, we've now gone through everything, so make sure your notes are complete and get ready to take this to the next level.
Hey, let's finish this video right. Alright, so everybody that's watching, you guys know me, it's Mrs. Phelps. So here's how you're going to prove that you actually watched this video all the way to the end. In your notes, you are going to write that Mrs. Phelps rocks. Make sure you have that S there. Do not put Mr. Phelps rocks. That is not okay. Okay, and then to top it off, you need to high-five me in the hallway. That's right. Don't mind how retarded that hand looks. All right, high-five me in the hallway. That proves you finished the video. Good night.